Okay, so this is the video for section 6.5 for geometry, rhombi and squares. So the first thing I want to talk about is just what a rhombus is. By definition, it is a parallelogram with all four sides congruent. So we already know it has every property of a parallelogram because that's the definition of it. And then all the four sides are congruent. A rhombus has all the properties of a parallelogram and two new additional properties described in the two theorems below. The first is that its diagonals are perpendicular. We talked about this in class, but what ends up happening is when you draw on the diagonals, you actually get four triangles that are all congruent to each other. And so they end up creating four right angles here in the center, so they're perpendicular to each other. The other property is since they create four congruent triangles, you get opposite angles bisected by the diagonals. So the two properties specific to a rhombus are diagonals are perpendicular and the opposite angles are bisected. A square is a parallelogram with, that's our second shape, is a parallelogram with four congruent sides and four right angles. So it has all the properties of a parallelogram. And then the parallelogram, the square also has four right angles like a rectangle does, so it has all the properties of a rectangle, namely that the diagonals are congruent. And it's also got four congruent sides, so it's also got the properties of a rhombus, meaning it's got diagonals that are perpendicular and the diagonals bisecting the opposite angles. So the way I like to kind of explain this in class, and if you're in class paying attention, you heard this, is there's a Venn diagram drawing of this, and basically it's the fact that you've got all parallelograms. Okay, here they are on the outside of this figure here. Parallelogram here, parallelogram here. And then you have rectangles, which are parallelograms with four right angles. Then you have rhombuses, or rhombi, where you have parallelograms with four congruent sides. And then they basically kind of get married and have a kid, and it turns into the square. So it's kind of a weird way to describe it, but that's basically what happens. Okay. And after we work through and solve problems and homework with the rhombus and the square, the book presents basically four extra theorems for us for how to prove that you have a rhombus or a square. Yesterday in section 6.5, or 6.4, excuse me, we proved that we had a rectangle if we knew it was a parallelogram and the diagonals were congruent. Now we know it's a rhombus if it's a parallelogram and the diagonals are perpendicular. That's the first way right here. If the diagonals of a parallelogram are perpendicular, parallelogram is a rhombus. 6.18, if one diagonal, and this is important, it doesn't have to be both, just one. If one diagonal of a parallelogram bisects the opposite angles, then we know it's a rhombus. So the diagonals bisect both pairs of angles, but to prove it's a rhombus, you just have to bisect one pair. And then number 19, if consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Hopefully this one's kind of obvious, because if this is true, then we get this, where this is congruent to this. We know these guys are congruent. We know opposite sides are congruent. Therefore, it makes for us a parallelogram. Yeah. So, and then the last one here, number 20, if a quadrilateral is both a rectangle and a rhombus, then it's a square. So it's kind of annoying. To prove something is a square, you have to prove that it's a rhombus and a rectangle. Okay. So let's look at some problems from the homework then. I'm not going to go over every step of these problems of the proofs. I'm just going to kind of walk through the general idea. Oh, first of all, my daughter got to this before I was able to stop her, and she was drawing me a heart. So I thought I'd keep it and just, yep, that's what my daughter decided to draw for me on these problems. So anyway, for 14, we're going to prove that given QRST is a parallelogram. We know that. The question is, and we know that TR is congruent to QS. So here's TR. Here's QS. Okay. We know those guys are congruent. And we know that QPR is 90 degrees. So QPR, this is Q, this is P, this is R. This angle is 90 degrees. We want to prove that this is a square. Okay. So what we're actually going to piggyback off of is that last theorem, 620. It says if a quadrilateral is both a rectangle and a rhombus, then it's a square. So what we're going to do is we know it's a parallelogram already. So that's taken care of in the given. we're going to prove that it's a rectangle and then we're going to prove it's a square. And if we do that, then we can say, hey, it's a square, prove it's a rectangle, prove it's a rhombus, excuse me. And then once we know it's a rectangle and a rhombus, we can say it's a square. So I'm not putting this in the two-column proof form just because I'm trying to keep this video shorter, but that's our general process for this. We can prove it's a rectangle pretty easily. TR and QS are diagonals. So the diagonals are congruent. We can prove it's a rhombus because the diagonals are perpendicular and we know it's a parallelogram. Okay. And then how do you prove it's a square? It's both a rhombus and rectangle. Okay. So in the proof you would say, okay, you know, given all this, that's step one. Step two, QRTS or QRST is a rectangle. Reason, the diagonals are congruent. Okay, if the diagonals are congruent, it's a rectangle. The next step, it's a rhombus. Why do you know it's a rhombus? Because we've proven the diagonals are perpendicular because that was given with the right angle. Then the last one, okay, prove it's a square. Why is it a square? Because it's both a rectangle and a rhombus. So that's number 14 from the homework. 16 from the homework. Okay. Your job is to prove that if we have two parallelograms, ACHD, excuse me, and BCDF, and then we know that BF equals AB, excuse me, we don't need that mark yet, prove that ABFH is a rhombus. Well, we're going to prove that ABFH is a rhombus by basically showing that we have opposite sides congruent. Okay. So we know to begin with that this guy's a parallelogram, meaning that BF and CD are congruent. And then we know that the big figure ACHD is also a parallelogram, meaning that these two guys are congruent. Okay. So it gives us three congruent sides here. So that would be something we'd state out. Another thing is a hint to help you out with this one. We'd also know that these two guys are parallel because since these guys are parallel, because it's a parallelogram, and these guys are parallel because this is a smaller parallelogram, if two lines are parallel to the same line, they're parallel to each other. So we'd also already know this. So we've got a pair of parallel sides and a pair of congruent sides, meaning it's a parallelogram. We haven't used that. That's that theorem 612. We've barely used it, but this is where we're going to use it today. And then the last thing would be, okay, we've got a parallelogram, and because since we have a parallelogram, we've already proven that. So AH and BF are parallel and congruent. We can prove it's now a rhombus by, where'd mouse go? Come on, mouse. There we go. By theorem 619. If one pair of consecutive sides of a parallelogram are congruent, it's a rhombus. Now the last problem in the homework I want to take a look at is problem number 22. And I'm not going to go through all of it because again it's too much time. I'm trying to keep these under 10 or 12 minutes. But the idea for this one is plot it out. So negative 1, 1, 4, 1, okay, 4, 6, which is kind of off my scale, and negative 1, 6. And what you're supposed to do is, by looking at it, classify what type of shape it is. Now, if we loosely classify it, we can see that it's a parallelogram clearly. And it might look like a square, but it's actually not because this side is 4 and this side is 5. So, we don't unfortunately have a parallelogram. We just have a rectangle. So what you could do is, the easiest way to probably do it is to find the slope of all four sides and show that they make right angles, meaning it's going to be a parallel. It's at least a parallelogram and a rectangle. And then you could also show their right angles, or you could do the distance formula to show that the diagonals are congruent. So for 22, once you plot it out and take a look at it, it looks like a rectangle, which means it's not a square. So we can't prove it's a square. We can't prove it's a rhombus either. So we have to go with something else. So again, to be a rectangle, you give the slopes to show that the opposite sides are parallel and perpendicular, like we did in class yesterday, or you could find the diagonals and show that they are congruent by using the distance formula. So hopefully that helps. Again, it's not everything on that section, but it's a few problems that kind of a run through of the basic ideas again.